domain problems. And we're going to see if we can write our answers in interval notation. So let's try f of x equals (3 over x). So again, when you're doing domain, you got to think about what numbers can I plug into this? Or maybe the easier way to think about it is, what numbers can't I plug in? And then the domain is everything else, right? So, any numbers that are bad for this one? 0, right. So, as long as it's not 0, though, every other number should work, right? 0 is the only bad number for this. So our domain needs to be anything that's not 0. So what are our intervals? Because there's 2 of them. From what to what?
Negative infinity, 0,
Yeah, exactly. Negative infinity to 0. All those numbers are good, right? Do I include 0?
No.
Nope. And then there's another interval. Again, I don't include 0. And all the numbers from 0 up to infinity. Both of those 2 intervals are part of the domain. Okay? So, technically, the way that we describe this is it's the union of those 2 intervals together. Okay? Union means together. So, the notation we use, hopefully you made a little space here. We'll put a little u in between it. Okay? So, it's the union of negative infinity to 0 and 0 to infinity is the domain of that function. So that's describing all the numbers in those intervals are ones that are going to work. Let's try do another square root one here. What the square root of x minus 2? So think about what numbers can we plug into that and what numbers can't we plug into that. So maybe start with a little kind of guess and check. Can you put a 0 in? 0 doesn't work because we end up with the square root of negative 2. Can you put it in a 1? Nope. Can you put it in a 2? Yep. No, you can put it in a 2. Because what's it going to be if you plug in a 2? Square root of 0, which is what? 0. So technically that one does work, right? So, and then as long as you keep getting bigger than 2, you're still fine, right? It'll come out positive. So, 2 or bigger, right, is our domain for this. So, can you write that as an interval for me? What am I going to start with? Bracket. And then what comes next? 2. And then how far up does it go? Infinity. Yep, we can keep going. And what comes after the infinity then? Parenthesis. Yeah, because we always parenthesis in infinity. Okay, so 2 to infinity, including 2. That's your domain for that one. Good. Okay. This one will be a little challenge to see what you remember from Algebra 2. The natural log of x. Anybody remember what numbers you can put into a log and what numbers you can't? Yeah? Nope. You can put in a 1. It comes up to 0. Anybody else want to hazard a guess? Has to be positive. Okay, this one's sort of like, it's similar domain to that of a square root. Thank you. But you can't put in 0. Log of 0 is undefined. Log of anything negative is undefined. Okay? And we discussed that last year in Algebra 2. So the domain for this is 0 to infinity, but not including 0. Okay? So it would look like that. All right. So a natural log is the inverse of an exponential. So think about how an exponential works. And x and y then are switching roles. It does the opposite. It undoes an exponential. Okay. So last example here. Let's do x plus 3 over the square root of x plus 2. So I start doing like some kind of combination stuff here. So again, you got to think about, what do I have? What are going to be some bad numbers to plug in here? That's going to make it undefined, make it not work. As soon as I see a square root, my attention goes right to that. Okay? So in that square root, ignoring the whole rest of the problem, just in the square root, what works? Anything bigger than what? Negative 2. Okay. So, if it was just the square root, it would be negative 2 to infinity, including the negative 2, right? But look at where I put the square root. If I were to plug in a negative 2, would it work? Why not? It's in a denominator, right? So if this denominator ever comes out 0, that's still bad, right? So negative 2 is not a good number. So my domain then is negative 2 to infinity, but I just don't include the negative 2 then. Okay, that one number is still going to be bad. So it would be this. All right, so when you start throwing some of those little combination things at you, it gets a little trickier, and you got to have to kind of think through it a little bit that way. But always, if there's a mix, start with that and then work your way out from there. In general, there's 3 rules you need to follow. That'll help you with these. We'll discuss in a minute. Yeah.
How come it can't? I thought it could be negative 2.
It can't be negative 2.
So why is it not?
Because parenthesis means you don't include the number. If it was a bracket, that would be bad. The bracket, you include it. Okay, so our 3 rules that we need to follow when we're doing domain work. So we're looking for gaps in the domain, because really we said it's easier to look for what doesn't work, and then whatever else is left over, that's your answer. So gaps in the domain can be created by basically just 3 things. Number 1, and we saw an example of, a couple examples of this, can't divide by 0. So if there's any kind of a fraction in the problem where x is in the denominator somehow, you're going to be playing with that one. Number 2, square roots of negative numbers. So if your function has a square root with x underneath it somewhere, you're going to have to work with that one. Okay, what numbers are going to make the square root have a negative underneath it? And then logs of 0 or negatives. So you're looking for fractions, square roots, or logs. If your function that you're looking at doesn't have any one of those 3 things, the domain is always going to be the same thing. And what's that, do you suppose? what numbers would work? Negative infinity to infinity. Yep. Okay. And a lot of times that's the domain of what you're looking at. When we do that look at all those different functions that you guys are going to present to the class next week, most of them, that's their domain. Negative infinity to infinity. You're going to see that a lot. Okay. The reason I did these kind of functions over here is because these are the ones where then you got to start thinking about, oh, how do I need to change that domain? Because where's the gap? And how's that going to change how I write my domain? So, okay. So that's domain in